Up our matrices and system application notes with two last examples. So we are using this position equation where S would be our position, 1/2 AT squared plus V naught T plus S naught. Now, if you're in physics, this is going to look familiar to you. If you are not, let me break some of this down for you. So, come on, focus. There we go. Now, S would be our position. Usually this is like a height. A is our acceleration. T is time. This V naught would be our initial velocity. And S naught would be our initial position. So that's what all of these different symbols, variables mean. So we're given again some values and at times. So when our position is 128, the time is 1. So there's 1 point. When our position is 80, the time is 2. And when our position is 0, the time is 3. So this is similar to that quadratic one we just solved, but our equation is slightly different. So we're going to be looking to solve for A, V naught, and S naught. So our acceleration, initial velocity, and initial position. And again, this is our position, and that's the time. So let's write our equations. So 128 is equal to 1/2 A times T squared plus V naught times T plus S naught. So 128 is equal to, that 1 squared is just 1, so we'll just say 0.5A plus V naught plus S naught. So there's our first equation, and I'm going to go ahead and highlight it. Then our next one is going to be that 80 is equal to 1/2 A times 2 squared plus V naught times 2 plus S naught. So 2 squared is 4 times 1/2 is going to leave us with 2A, 2 V naught, and just our S naught. So there's our second equation. Then our last set, 0, 3, so 0 is going to be equal to 1/2 A times 3 squared plus V naught times 3 plus S naught. So that's going to give us 3 squared is 9 times 1/2 gives us 4.5. And here is my third equation. Now again, when we're writing our matrix, we want all of our constants on the right and all of our variables on the left. So let's rewrite these in that form just so we can keep it clear when we're filling out our matrix. So I am just swapping where the equal sign is. And so there are my three equations. And our matrix is going to be a 3 by 4. So all of our A's are going to go in that first column. All of our V naughts are going to go in that second column. S naught, and then our constants. And that's just an 80, not an 86. So again, back into our matrix calculator, edit. I'm just going to go down to C. It's a 3 by 4. Oops, not. There we go. 0.5, 1, 1, 128, 2, 2, 180, 4.5, 3, 1, 0. Okay. So then down to math, RREF. I put that in matrix C. And we get that A is negative 32, V naught is 0, and S naught is 144. So what this means is my acceleration is 32 in the negative direction. I have no initial velocity, and my initial position is 144 in the positive direction. So we're plugging these back into our A, V naught, and S in our position equation. So the position is going to be 1/2 A, 1/2 times negative 32, that's going to be negative 16A. Plus, I had no V naught, so that's going to go to 0. And then my S naught was 144. So that is our position equation. Okay. Last example, and this is going to be similar to how your homework needs to be done. So we're receiving a total of $1,520 a year from 3 investments. Our investment rates are 5%, 7%, and 8%. The 5% investment is half of the 7%, and the 7% is $1,500 less than the 8%. What is the amount of each investment? So the first thing we need to do is define our variables. We can use X, Y, Z, A, B, C, anything you'd like. So X is going to be our amount for the 5% investment, or whatever variable you choose. Then we're going to have the amount for our 7% investment. And then our third one will be the amount for the 8% investment. Okay, so we're looking for the amount of each investment, and I have 3 investments. So there's my X, Y, and Z. So now we need to use the information we were given to write our 3 equations. So the first equation is helping us out here by narrowing it down. This is going to come from the interest rates are 5%, 7%, and 8%. So 5%, we need to rewrite these as decimals. So remember, you move the decimal place over to the left 2. So 0.05, 0.07, and 0.08. So 0.05 times how much I invested into my 5% investment plus 0.07 times the amount I invested in my 7% investment plus 0.08 times the amount I invested in my 8% investment gives me a total return of $1,520 a year. So there's my first equation. Okay. My second equation, the 5% investment is half of the 7% investment. Remember, our 5% investment was X. Is tells us I'm going to have an equal sign. Half of the 7% investment. So half of my 7% investment. Then my third equation, the 7% investment is, so remember this was Y, is $1,500 less, that means minus $1,500, than the 8% investment. Okay, so here are my 3 equations, and if I'm going to use a matrix to solve these, remember I need my equations in standard form. So our equation 1 is already in standard form, but let's rewrite these 2. I'm just going to move that 1/2 y to the other side, and that's going to leave me with 0. So everything on the left, constants on the right. This next one, I'll just move y over so that all of my stuff is, I'm just going to move z over so my constants are on the right. So y minus z equals negative 1,500. Okay. So what is our matrix going to be? Remember, all of our x's, all of our y's, all of our z's, and then our constants. So that first one, x, y, z, constant. My second one, I'm going to have 1, 1/2. I have no z's, and that equals 0. Then my last one, I have no x, 1y, negative 1z, negative 1,500. Should actually be negative 1/2 because I had the minus 1/2 y. Okay, so now let's go into our matrix. I'm going to put this into matrix D just because it's open. So this is a 3x4 matrix. 0.05, 0.07, 0.08, 15, 20, 1, negative 0.5, 0, 0, 0, 1, negative 1, 1,500. Again, making sure you're using the negative button and not the minus button. Oops. And we're going to tell the math menu, RREF, that was matrix D. And so we get that X is 4,000, Y is 8,000, and Z is 9,500. So what does that actually mean? Let's write a sentence explaining what this means according to our defined variables. Remember, X was our amount for the 5% investment. So I invested $4,000 into the 5% investment, $8,000 into the 7% investment, and $9,500 into the 8% investment. And that shouldn't be they. So that's what your homework should look like. You should have your clearly defined variables, your equations, your matrix, and then a sentence explaining what your answer means.